Excellent. So, welcome to our series Innovation at the Edge. Today, we are hosted by the UCSD Office of Innovation and Commercialization. For those of you who haven't spent enough time with us, you can always find out the programs and services available for what we do at innovation.ucsd.edu. It's got a complete calendar as well as access to a series of resources. We do everything from classes and workshops to events around entrepreneurship, and we bring together not only the San Diego community, but all the resources, the rich resources here at UCSD and beyond. Today, we're lucky to have author and scientific mind, Sam Arbesman, scientist in residence from Lux Capital, but he's so much more than that. And he's written a new book, which we've got here, The Magic of Code. So we're going to talk a little bit about the book, what's in it, and what's beyond, but also why he wrote this book and what it really means for us. What does he want to kind of us to take away from this? And then explore kind of where this field is going to be taking us going forward. Later on, we are going to be joined by the dean of our newest school here at UCSD, the School of Computation, Information, and Data Science here, and Dean Rajesh Gupta will be here a little bit later for you to meet and then talk about it. So this is very opportune that we're able to have this conversation. So let me introduce Sam, and I'd like to start by just asking you not only to introduce yourself, but tell us a little bit about your background and the journey that kind of got you not only here today, but got you to writing the book.
Yeah, well, thank you very much. And yeah, thanks for having me here. Good to be talking to all of you. A little bit about kind of myself. I'm currently Lux Capital Scientist in Residence, which is a fun title, doesn't necessarily give you a sense of what I do, but so Lux is a venture capital firm that invests in emerging tech, deep tech, frontier tech. Probably the more fun and even potentially more accurate way to describe it is anything that feels a little bit like science fiction. That's the kind of thing we're thinking about. And so my role is to survey the landscape of science and technology and find areas and individuals and communities that could be relevant either to the companies we've already invested in or the kinds of things that we might eventually want to invest in farther down the line. So I'm sort of upstream from investment, finding areas that we want to bring into the orbit of Lux. Now, in terms of kind of how I got to there, or I guess to here, as well as kind of writing the book. I am a scientist by training. I got my start in, originally I was doing a PhD in computational biology. I was very interested in trying to understand the nature of evolution using computational and mathematical models. But then during my graduate school program, I was also part of this interdisciplinary fellowship program related to complexity science, kind of trying to understand large systems with huge numbers of interacting parts. It could be biology, it could be social systems like cities and even the planet of interacting individuals. It could be technological systems. And turned out there's a whole suite of math and computational ways of understanding these kinds of things. And so I got very interested in that and then sort of moved more into that. And then alongside this began thinking a lot about trying to use these techniques to understand the nature of scientific and technological change and trying to actually see if you can use math and computational modeling to understand this. And so that actually led to my first book, which is called The Half-Life of Facts, which is about how what we know changes over time and kind of the regularities behind knowledge growing and changing and error spreading and then eventually being rooted out and all these different kinds of things. And then eventually to my second book, which was about, it's called Overcomplicated, about the nature of technological complexity and the way in which technology has become more and more complicated and increasingly incomprehensible, even for the people who built these systems and work with them on a daily basis. And then most recently, this book, The Magic of Code, this is kind of my attempt to try to, I guess, sort of, if I want to go really broad and kind of grand, it's almost like trying to actually fix what I view as a somewhat broken conversation around technology. Right now, when we talk about tech, it's often adversarial, or there's lots of worry, and we're concerned about AI or social media, or phones are ruining kids and things like that. And all these are fair concerns. But for me, when I think back to my own childhood and kind of my own experience getting involved in computers, it was much more it was full of wonder. Like I kind of grew up. My first computer was the Commodore VIC-20, where you used cassette tapes and you connected to your television, and you hand coded it. Even though I was not the one coding, it was my father. And I saw this kind of real relationship between the text you were writing and what was going on the screen. And eventually, then we got a Macintosh, and then I learned about screensavers and fractals and SimCity, and it was just this very, very exciting moment. And I feel like we've kind of forgotten all the different ways that computing can be exciting and also more at a human scale. But in addition to that, also the way in which computing, it's not just a branch of engineering that, for me, when properly construed, it should be almost this like humanistic liberal art that connects to language and philosophy and biology and art and how we think and all these different things. And so the book was kind of my attempt to try to connect all those different ideas together, but also in many ways trying to, like, this is the kind of book that I wish I had when I was young and first getting interest in computers. And so this is my gift to future little Sams. Kind of hopefully they can get interested in computing and find the wonder at kind of that human scale, as opposed to just viewing it as this cause for concern, and kind of this thing that's just so much bigger and really almost hard to interact with and engage with.
So as you went through kind of not only the research but the work behind it, were there any things that particularly surprised you, or that you went in saying, I thought I kind of knew kind of something about this, and then I stumbled upon something that kind of changed the way I then looked at this?
Well, I would say one thing that I spent a lot of time thinking about is just the history of computing, and and I would say time after time, whenever I was studying, I don't know, people trying to model like the nature of life within computers, or trying to make it so like democratize software creation, where not just software developers are building things, but anyone can build it, or even things about like thinking about the history of programming languages. It turns out, or like large scale simulation, all these things, and even AI, all these things which are very relevant right now, they were they were relevant and actually happening almost at the very inception of the modern digital computer. And I feel like time after time, as I would begin to research these things, I would find out that none of these things are new. They were all kind of present at the inception of computing. And and it happens, I'm very interested in the history of technology and history of computing. And I feel like less and less are people actually engaging with that, especially in the tech world, where I feel like there's, I don't know, a certain amount of like historical ignorance when it comes to technology, and sometimes even proud ignorance, where it's like we don't care what came before us, we only care about the things that are new. And sometimes it's good to just build new things, but oftentimes if you don't understand that path dependence, the deep history of all these kinds of things, you end up reinventing things and spending a lot of time like rediscovering things that have been known for many, many years. So, like, for example, like all the conversation around AI, where people are talking about like the alignment problem and unanticipated consequences and how we think about jobs. These things, they're not new concerns. And so actually, one of the things that I discovered during the process of kind of researching these ideas was, so Norbert Wiener, who is the developer of cybernetics. He has this wonderful little book called God and Golem Incorporated. And in it, he talks about basically all the concerns about AI that we are thinking about now. So these things are not new at all. And I feel like just time after time, I saw those kinds of things.
Now, in your book, you actually talk about this concept of code is a language, as we kind of move from these kind of physical realities into these kind of these digital worlds, which we now disproportionately spend our time. The code is the underpinning language. How has that language kind of evolved, and will eventually this thing be not so much understandable to us, the language?
Yeah, I mean, so yeah, programming, and for me, I mean, when I learned how to program, I was learning like C or C++ or Java, and then Python and Perl and things like that. And they're all, and some are, there's variations obviously among those different languages, but they all are kind of like these weird sort of like hybrid between mathematics and English. But the truth is, right, programming has always changed. And so if you like go far enough back, I mean, very early days, like with the ENIAC, that you were actually like physically plugging wires in and cables and flipping switches, and then eventually it became like writing binary strings, which then eventually became writing like assembly language, and now we have these kind of higher languages. And of course now it's changing yet again with AI, and actually like whether it's vibe coding or kind of using it as an assistant to actually, you give it your desires and then it writes a program which sometimes aligns with the things you want, sometimes not. Right, it's always been this moving target. And I feel like, so I would say, I guess, two things. One is when I think about the way in which code is a language, the way in which it is a language, kind of, at least in terms of like the kind of traditional programming languages that I was used to. It feels like a really good analogy. And in many ways, actually, not only is it a good analogy, but and going back to like the title of the book, like it actually accords nicely with this idea of like sorcery, of like, oh, like using text to kind of coerce the world around us and actually kind of change things and like create these computational spells that actually do things, where it's both really powerful, but also requires a great deal of effort to actually kind of get the language right. And if it was binary, it wouldn't feel as magical because it would just be a lot of work. And if it's now with AI, it would feel magical, but in a very different sort of way. Not necessarily in the way where magic requires work, but more just in in the way that it just feels magical and just kind of works. And so I feel like when we think about what are languages and programming languages, it's always going to be this kind of moving target. That being said, I think no matter what kind of language or what kind of way we get our computers to do the things we want to do, it's ultimately part of this process of kind of taking whatever is in our heads and actually getting the machines to do that. And so actually one of the way to kind of, for me to think about this is like kind of putting these all in sort of a tradition, is I mentioned this story, I think near the beginning of the book. So if you look in the ancient Jewish Talmud, there's actually this kind of weird story where Moses is talking to God, and God is doing something and saying like, oh, like there's going to be this like scholar, I don't know, thousands of years in the future who's going to be unbelievable. And Moses says, oh, show them to me. So then they time travel and they go into like the house of study and they're learning. And this guy is talking about things that Moses doesn't understand, and which is kind of surprising because Moses is ostensibly the one who's received the law. And then at the very end, this scholar says, oh yeah, and the way I understand this is because of like the law of Moses from Sinai. And at that point, he's calmed because he realizes that even though he doesn't understand what's going on, he knows that he's part of this long tradition. And I feel like the same kind of thing is true with code. Where like, I can't write code in binary. I certainly can't do the kinds of things that Steve Wozniak did when he was developing the first Apple or Apple II. But I know that it's kind of part of this long sort of programming tradition. And of course, the things that are going to happen next when we are using AI to build these kinds of things, that is also going to be kind of part of that tradition. Now, whether or not it makes us a little bit more distant from our machines because we're kind of using this higher level language of just regular English to actually command our machines to do things, yeah, that will change things. And I think it actually might make us a little bit more distant from those machines. At the same time, though, I think like there's always been a certain amount of distance, and we kind of have to figure out at what level we are comfortable with it. I also do think that actually understanding like lower level programming can still be useful. I don't think it's going to be an either or kind of thing. But anyway, that's a long way of saying programming has always changed. What the language is has always shifted. I think there's a great deal of power in looking at ways in which natural human languages are similar or different to programming languages, and we can talk about that as well. But yeah, it is this weird thing that we're able to kind of coerce our machines with.
We see, because you talked about your research in complexity, and with the introduction of a digital world and the tools to be able to do that, we've accelerated not only knowledge creation, but we've also accelerated the amount of digital vomit that just kind of hits us
Yes.
every day. And it has this great ability just to overwhelm, because technical operating systems appear to have gotten far out ahead of our own human operating systems. We can invent at rates faster than ever before. There's all this stuff coming back to us. And our Paleolithic brains, as E.O. Wilson said, you've got these primitive brains, medieval institutions, and godlike technology, what that's obviously presenting. How do we deal with that?
I mean, it's a tough question because I totally agree that like, as we build these massively complex technological systems, we are reduced in our ability to understand them, and sometimes it's not. And the truth is, it's not even like the massive data centers or the entirety of the internet or some other kinds of large complex systems. It can be like these laptops, like no single individual understands everything that is going on in all of them. And that's a good thing by and large. Like we need tools for abstraction to actually kind of compartmentalize and have expertise and specialization. The downside is that oftentimes we don't have a grasp on the whole. And sometimes we don't realize that until things are too late, and then there's some sort of glitch or failure, and then we realize there's a gap between how we thought the system was actually going to operate and how it actually does operate. That being said, when I think about understanding, I don't think of it as like, it's not these like two extremes of either like complete and utter ignorance and total understanding. Like there's a lot in between, and I think we've always been somewhere in between when it comes to our technologies. And as our technologies get more complex, it's incumbent upon us to actually find ways to gain more and more understanding. And so, yeah, and actually one of the things that I think a lot about, going back to my roots in biology, is biologists for hundreds of years have contended with systems that are very complex and they don't know how to understand, which are just organisms and ecosystems and things like that. And increasingly, as technologies are becoming as complex, or maybe not quite as complex as biological systems, but increasingly more complex, we can actually use some of the techniques that biologists and ecologists have used to understand these large technological systems of our own making. So there are ways to kind of make it a little bit easier to understand.
So I agree with you that we're kind of entering this kind of almost age of biology where even the biological models can be used in a lot of our digital and computational models. Can you give the group maybe some examples of what that might be?
Oh yeah, and there's actually this great paper. I don't remember. Probably sometime in the past 10 years, where it was looking at a very simple processor. I think it might have been maybe a video game processor from like some early generation, and a team of neuroscientists actually took it and tried to use neuroscience techniques to actually understand what was going on in the processor. And it was kind of this weird thing where they used these techniques, but they also showed that they were both. So it was they were actually woefully inadequate, which I think was both humbling for technology as well as for neuroscience. But I would say more often the way to kind of think about this is by looking at the ways in which I would say the example would be like field biology. So like field biologists would you go out into the field and you just collect things and you start taxonomizing and classifying. And the truth is that is the precondition for better understanding large complex systems. And one of the things in the way that people collect insects, we can actually kind of turn it a little bit on its head and say, collect bugs. In this case, collect failures and glitches. Because going back to what I was saying, failures are actually the way in which you actually learn more about a system, and you are able to find that gap between how you thought something was going to work and how it actually does work. And so, and that's how biologists work. They actually will, I don't know, submit a whole bunch of bacteria to radiation to actually mutate them, and then use that as a window into understanding whether or not those mutations matter that much or not that much, and it's like trying to understand which genes are important. And you can actually do the same kind of thing in technology where you're not just waiting for failures to happen. You can actually inject failures into systems. So Netflix, they actually developed this system called Chaos Monkey. It's been around for, I think, over a decade at this point, where what it does is it just periodically takes various subsystems down randomly, and while things are not, I guess, like under a great deal of pressure, in order for the engineers to make sure there's as small a gap as possible between how they actually think it's actually going to work and how it actually does work, and make sure that things are as robust as possible. Similarly, developers who are involved in supercomputer design will actually occasionally just randomly flip bits to see whether or not those kinds of things matter. Because especially when you have a very large computer or a very large data center or system, these things are all computers are sensitive to cosmic rays, but when you have a very large computer, that actually is a non-trivial problem, and so you have to actually test for randomly flipping bits and things like that. And so those are some of the techniques to kind of that you can kind of import from biology to better understand these large technological systems.
Well, seeing as we have a lot of students here,
Yeah.
and people, both undergraduate and graduate students, how do they prepare themselves for work in this world where 3 years after they graduated, what they may have learned will be completely different?
Ooh, that's a good question. I think more broad. I'm not sure I'm going to be able to give that much specific advice. I would say the kind of thing that I love thinking about is more just the overarching mental models that are useful no matter what system you're kind of looking at. And so whether it's mental models to understand large complex systems, whether it's mental models to understand certain technologies, things like that. So for me, going back to the idea of complexity science and complex systems, it turns, I mean, all of these systems are special in kind of their own specific ways of like trying to understand an ecosystem or trying to understand a city and the way it innovates or does certain kinds of things or the way an organism metabolizes. But it turns out that underneath all those differences, there are actually certain regularities. And people have actually developed a number of different like network models or mathematical models to really understand these regularities. And I would say understanding those kinds of models could be increasingly useful as we are going to increasingly contend with these systems, both in kind of the natural and constructed world, as well as sort of just the world as it is. And so I would say certainly complexity science is one thing, but also actually going back to like my first book, The Half-Life of Facts, of like dealing with like rapidly changing knowledge. I I remember there was a period, it's probably like close to like 15 years ago now, when people were concerned that like the advent of the internet was going to like ruin everyone's memories and it was going to be terrible. And I actually think that's not necessarily a bad thing, because it's much better to look something up and make sure you have the most up-to-date knowledge rather than relying on some half-remembered fact that is woefully out of date. And so for me, yeah, that's more just kind of a larger call of just like constant, like knowing like the art of like learning how to learn so that you can constantly update these kinds of things. And so you're not, I think when I was writing the Half-Life Facts, I heard this story about some like, I don't know, hedge fund manager or investor saying like telling some story and like, oh yeah, of course, like we're gonna do this kind of thing because as we all know, like there's 4 billion people on the planet. And of course that was like billions of people out of date. And like, I don't want people to make those kinds of out of date decisions. So it's really just more, yeah, constantly updating information, which is, I mean, sort of trivial, but I still think is underrated.
But as a university, so much of our kind of past historical legacy was building experts and expertise. People who go out in the world and are valued because not only they have that expertise, but because that then implies that they make fewer mistakes and waste fewer resources in the world. And all business on the business side is predicated on efficiency and profitability, you know,
Yeah.
for what they do. Now we're entering a time where we're putting stuff out there where we have to rely on more and more uncertainty and ambiguity, and we can't rely on that certainty. So that very much shifts the nature of, instead of just hiring people that just purely have expertise, hiring people who can adapt very rapidly to dynamic circumstances.
I really feel that, yeah, that kind of adaptive ability, kind of a more generalist approach or polymathic approach or kind of like T-shaped individuals or whatever we want to call them, those kinds of people are going to be increasingly important. The major issue is, I think right now, like convincing organizations that it is important to actually have those people in addition to kind of the experts. I do see that increasingly organizations are finding a place for kind of outlier roles, whether it's kind of a weird generalist or just someone who's kind of like playing with ideas more broadly, because they realize that like, on the one hand, it's important to have experts and specialists kind of monomaniacally focused on the specific thing they're doing. But if they're only focused on those kinds of things, the organization as a whole is going to miss lots of different kinds of opportunities, and finding outliers or kind of more generalist kind of thinkers, that's going to be important. And then right now, I think it's the role for educational institutions to find ways to actually cultivate those kinds of people, so that they will have the skills, so that when these organizations realize that there's an increasing need for them, they will be available.
So now in your role advising kind of Lux Capital, not only on kind of the strategy, but kind of how they should look at the future and how they allocate their own capital, how does this then kind of translate into that? One is that the future is rapidly changing. There is this half-life of facts. And so how do you then build a strategy and a thesis around that?
Yeah, I mean, so I'm not. I mean, I'm not sure there is a clear strategy or thesis, and I think to a certain degree that I think is by design. I think so. One of the partners at Lux, he always talks about kind of creating conditions of randomness and optionality, and I think that's sort of my role as a kind of this weird optionality machine. And I think increasingly, when the world is becoming more ambiguous and more uncertain, you need to create a space for that ambiguity and kind of messiness. And I'm reminded of there's a great book by Ken Stanley and Joel Layman called "Greatness" or "Why Greatness Cannot Be Planned." It's basically about the idea that when you are dealing with some complex high-dimensional system, such as the nature of innovation, it's very difficult and actually counterproductive to aim directly towards a single objective. Rather, what you should do is index on novelty and interestingness and kind of find interesting things and then use those as sort of stepping stones that can be productively recombined into novel ideas. And the idea, and I feel like that's the kind of thing where as the world is changing, the thesis is almost just find interesting things, which is not nearly as systematic as I think many people might want it to be. But I think there is a great deal of power in trying to find those interesting, weird things, because oftentimes those are just leading indicators of something interesting happening that maybe down the line will be useful for some sort of venture-backed startup or whatever.
So, what are some of the interesting things you're seeing?
Oh, that's a good question. I mean, so one area, and this is an interesting. So one part of my role is finding interesting areas, sometimes independent of whether or not they will necessarily be a good investment, even down the line. Oftentimes, just because those things are just inherently interesting or useful. And so, one area that I'm actually playing a lot with is thinking about the nature of non-traditional research organizations. So, right now, when we do research, we often do it in kind of one of a handful of different institutional forms. We do it at universities. We might also do it sometimes in startups or corporate industry labs. But the truth is, those are just like 3 points in some weird high-dimensional space of potential institutional structures. And I think we can actually be exploring that entire space, or we should be exploring it more. And happily, over the past 5 years or so, there's been this explosion of a lot of new types of research organizations where people are doing things that are maybe more interdisciplinary, so they don't necessarily fit within a single university department. People are trying to fund people rather than projects or domains. Things are maybe more distributed. There's lots of different kind of weird things that are happening, and a lot of these, I mean, they're not good investment bets, and most of them are actually nonprofits, so we can't even invest in them. That being said, it happens to be that oftentimes the most interesting people are often drawn to these kinds of institutions. And so from the Lux perspective, being able to kind of understand what is happening at that frontier is very, very valuable, because we don't really know exactly what these organizations are going to kind of throw off down the line. Maybe it'll be companies, maybe it'll be just interesting people, but we kind of want to be at sort of the epicenter of that kind of thing. So that would be one area that I've been playing a lot with.
I love that. Just looking out. Anyone have a question they want to ask? Yeah. Okay, I'll come down there.
Hi, Mike Saharik, grad student with Rady. As you're balancing perfection or thinking about, being a researcher, coding has to be perfect. Now you're segueing into AI. A startup only needs to be right once, not 100% of the time. How do you balance that day to day with people who are making investment decisions and being a scientist?
So can you say a little bit more? Can you say a little bit more about that? I want to make sure I understand.
Yeah, just your role as being a scientist where everything has to be perfect. How do you work with and kind of bridge the gap between the scientific minds who are so focused on that and then, the business aspect of it, where if you're right 50% of the time, that's a fantastic bet and 11 times returning.
Well, I'll say one thing. I mean, certainly based on my work, especially with like the half-life of facts, I mean, scientists are not always right. There's a lot of, I think we're kind of asymptotically approaching the truth, and that's great, and we want to kind of do that kind of thing. But along the way, things are going to be overturned, and that's kind of part of the process of science. And I think, and so for me, on the one hand, yes, you want to be as rigorous as possible with one's science. On the other hand, though, I think the scientific mindset ultimately is about recognizing that knowledge is constantly in a draft form. So one of my grad school professors, he told me the story where he came in on like a Tuesday and like gave some lecture, and then the next day he actually read a paper that invalidated everything he had taught. So then he came in, like went the next day to class, and he said, "Remember what I taught you? It's all wrong. And if that bothers you, you need to get out of science." And so I think there is so ideally that kind of mindset. I mean, obviously it's a lot tougher when it's your own research to kind of say, "Oh, this is great that everything's been invalidated," or "I'm kind of learning more." But I do think there is this kind of that constantly draft form sort of like that kind of mindset for scientists, which I think can accord nicely in sort of the entrepreneurial world, which is you are testing a whole bunch of different things, whether it's like product market fit or trying to de-risk certain kinds of things. And that kind of constant iteration, I think, is true. I mean, whether you're talking about like design thinking or certain things in startups, or you're talking about things in science, like that constantly iterating and testing and updating your theories is a mindset that you need for everything. And I think some people are better at it than others. Some domains, I think, kind of internalize this better than other places. But ideally for me, like that's the kind of thing that I want to see no matter what.
But kind of also building on what he just asked, that inside of an investment firm, you have to make a decision, but it's clear you have to make a decision often without incomplete
imperfect knowledge.
data sets. What is that kind of right balance? How do you know you have enough? And probably the right answer is you don't.
Agreed. Yes, you do not. You never really know for certain, and which is why many venture firms will kind of have all those like errors of omission and like all the bets that they missed, and those are the kind of things that often will like eat up the like investors, because if they make a bet and then it goes to zero, that's one thing. But if they fail to make a bet and then it goes to the moon, then you've kind of missed out on that massive upside. And so which means, though, on the one hand, you don't necessarily want to make every single bet, because of course that's not how averages and things work in a kind of heavy tail distribution. But yeah, it's very, very tough. Like you are dealing with a huge amount of incomplete data and information, and even the kind of information where you think you might have good information, but it turns out, like, I don't know, a few weeks later, the founders decide they're going to change entirely what they're doing. And so you realize you've actually just made a bet on the founders, not on the idea, which is often actually a better thing to do. But so it's always incomplete and subject to change.
Hi, my name is Rob. I own a software company here in town. I was talking about failure, or talking about changing your mental model. Can you give an example of something, a belief that you held strongly, or a mental model that you thought you had, that's definitely it, and then it completely changed out from underneath you?
That is a good question. I could probably give a whole bunch.
Because it happens all the time. It happens all the time.
So I give a lot. So one of them. So I have a number of situations where I've slowly but surely realized, and you were asking about things I'm interested in, kind of at the frontier. I've come to the understanding that I am very bad at prediction. So for example, when my first book came out, which was back in 2012, I was so glad that the book came out then, because I was certain that was going to be the last time books were in print. It was going to be like ebooks from then on out. And I was wildly wrong. And then I also remember it might have been around that time that I think it was Popular Science or Scientific American. They contacted a whole bunch of different people, because at the time I was doing a lot of research also around the nature of cities, and they said make some predictions around the future of cities. And I think I said something around these weird pods that can go on rails, and that was going to be this personalized rapid transit. And of course I wasn't even thinking about autonomous vehicles. And then of course, once autonomous vehicles came onto the scene, I was like, oh yeah, this is going to happen really quickly. And then of course it did not happen quickly. And so now I have a great deal of humility of just realizing I don't know what I don't know. But actually related to also the half-life of facts, this is not something that necessarily I was sure in my bones of, but in the book, so in the hardcover version of the book, I'm giving an example of how errors propagate, and the example I give is around this story related to how people thought that spinach had much more iron content than it did due to some sort of typo, and this is the reason why Popeye consumes spinach. And then it turns out, between the time the book went to press and the book actually was published, I learned that the story about the error itself was wrong, and that error had propagated for 30, 35 years. And so I was able to fix it in the paperback, and actually I wrote a whole article about this kind of thing. But it was this very humbling moment to realize where the nature of how I thought about error itself was itself error laden. And so at this point for me, I just have a very humble sense of I don't know what I don't know, and so I have to live my life with that.
That is what happens with the kind of maturity. They say on average on the venture side it takes about $10 million to train a venture capitalist, because that's how much money they burn through knowing that they're certain before they have this kind of humility, realizing that the best, and even in the best scenarios, you have a lot of interesting guesses, and that some of them. The other thing is that the models, when you look on a spectrum between things that are highly emergent and about to come into being versus those things that are maturing and becoming highly manifested, the models are completely different. These models, you can look at what is predictable and probable and apply math and physics and statistics. But as soon as you slide everything to this highly emergent, the best you're going to know is what is possible or what is plausible. And that's the best. And that's why we do these experiments to try it. But if you try to take these models and pin them over here, they completely break down. Not only that, they lead you into these kind of this false sense of security, like you actually have a certain level of certainty, which is why, so many of the people who do very, very good at investing at these early stages, you know, while they can be obsessed around data and try to understand as much as they can, they also invest a lot through their intuition and gut. They have a sense about the future and what is possible. Because when you think about it, when we invest in that early stage, we invest in the potential of an idea in the business and the potential that this group of people presenting can actually pull it off. And often that is the best we're able to kind of pull together at that point in time. Would you agree?
Yeah, no, I think that's really useful. Yeah.
Let me go back here and then up here.
So I have a question about, you're kind of talking about like generalist approaches and then sort of the idea of investing more in like teams and people and that sort of as like the center for innovation, and tying that in with like interdisciplinary approaches where you're probably going to see that starting in universities, and then obviously startups would emerge from the work that people do in those universities. But I'm trying to imagine that from sort of like a business perspective where you have, maybe an existing company and they have their budget established, they have their product, they have like their marketing strategy, all this stuff. And then there's a research and development budget. But then you go to this sort of approach where you're trying to look at like, you just have these people sitting around who are, kind of tinkering on stuff. And for me, that doesn't seem like a business would want to sort of run their business that way. So I guess I'm trying to understand, like, in this, let's call it like this new business model, like how is that realized, like that innovation or sort of the emerging versus manifesting technology, like where does that
Yeah, and so is part of the question also just this idea of like especially when like a startup is new, like is the ability to kind of have someone doing some weird thing like sort of a luxury that they often can't afford? Is that kind of what you're also going towards?
Yeah, it definitely came from like thinking about when economies are not doing well, like innovation would slow because there is cutting out of that. Like
Yeah,
companies can't afford to keep
Yeah,
people.
I definitely think many companies will not create that space for it, and certainly the larger a company is, oftentimes there's a little bit more slack for that kind of thing. I do think that relatively early on there should be this kind of thing, like maybe not necessarily at the outset of an organization, but oftentimes like even early on in a startup, like especially if there's like a team of co-founders, one of the co-founders probably has a little bit more of that role, who's kind of like exploring things a little bit more broadly. I mean, they're all very deeply involved in the company, but I think at least from my perspective, there should be someone who kind of is thinking a little bit more broadly, because especially going back to what we're talking about with like experimentation and kind of the scientific mindset, very early on in a startup, you might have a theory of how the world works and how it will respond to that startup, and that could be totally wrong. And so being able to have maybe a number of bets, or kind of being able to actually like redirect or kind of change strategies more rapidly, and actually have strategies like, or kind of weird ideas that you can kind of take off the shelf and try, that can actually be really useful. So I do think it's important. I do agree that in kind of an economic downturn, most companies will say this is actually a luxury they should not have. I happen to disagree, and I do think that potentially that could also be a competitive advantage, where if companies have that kind of thing, then yeah, maybe they can actually survive better than the other ones. But I guess that's also a hypothesis that can be tested.
Hi, Rich Santori. I'm an orthopedic surgeon and consultant. And I wanted to ask you a question about failure. One of Elon Musk's famous quotes is that I celebrate failure. I learn from my failures and I welcome them. So share with us the biggest mistake you made and how you can help the young people here learn to accept failure rather and not let them eat them alive, but to celebrate its occurrence and to learn from it and build in the resilience to learn from mistakes and accept them as inevitable.
Yeah, I love this. I agree that yeah, celebrating failure and viewing that as kind of a component of resilience is very, very important. It's often easier said. Like you can like try to teach that, but trying to actually like really imbibe that. I think some of it actually does come from experience. In terms of my own biggest failure, oh, that's a good question. I definitely remember. So when I was in graduate school, I was doing a lot of these like mathematical models and trying different things, and I think I went through many ideas. I don't know how many it was, but it was this kind of thing where I felt every single idea was going to be amazing, and like they all failed. And it was one of these things where like, it was like failure after failure after failure, and even the successes of like the things that I ended up putting in my dissertation, they weren't that great, but they were good enough that they let me graduate. But oftentimes, right, like my dissertation committee did not, well, I guess my advisor was aware of the failures, but the rest of the committee was not aware that I had just tried all these things and like threw tons of different research ideas out, all of which like were terrible in retrospect. And like and these were like entire domains that I was playing with, and it was very it was one of these things that like in the moment felt very disheartening. And right, and you often don't show that publicly or share it. And so I'm not, I feel like that's kind of vague. I'm trying to actually think, I feel like it's not going to be that useful for me to tell everyone just like some specific research problem that didn't work. But I do remember that it was like, it felt like years of just failure, like as part of the process of even getting my PhD, which is one of those things where I think if other people have like been in grad school, they sympathize with, and it's like one of those things like I almost like shudder to ask another like a graduate student like how like where they are in their PhD or how things are going, because you never know, because it could be like a terrible moment, and it's like until I was like right near the end of the PhD, like where I can kind of like see the light at the end of the tunnel, it felt really dispiriting. And so yeah, it was just a lot of failure to kind of get to the eventual success of getting out. Oh, I mean, I'm not sure if it's like accepting of it, but also it's like iterating, like realizing that like each failure is not the end point. It's like that is like that is kind of the raw material for the next thing, which might be another failure, but you can kind of keep on going, and eventually you'll succeed. And I saw this even when I started writing for general audiences. I part of that just involves like sending things out and getting rejected over and over and over, and yeah, this is just kind of that is the part of the process of success where yeah, that's always how it is.
Phil, one of the mistakes that they teach in entrepreneurship classes is you never should feel good about failure. You learn to accept that it's part of the process, because failure is never the end of the kind of journey. It's just the thing along the way. And that rather than calling it failure or mistake, just it's an unintended outcome of what you want to do. But that's also the way all of life works. Things happen and you react to them. You take in that information and then you kind of figure out what to do next. You pivot, you change, or you fix the problem and move on. So one is being so really what you want is more of this kind of tolerance, an understanding. You want to develop an actual relationship with it to understand that it isn't. But part of the way it works well in startups is that you kind of share kind of this, that first of all, we like people to fail early and often as opposed to big. In fact, there's a joke in the Silicon Valley that the reason none of our buildings are really more than 3 or 4 stories is because when you jump off of them, you never get hurt. So it's that kind of sense that you do these experiments, you get the feedback, you fix it, rather than getting so far out ahead of your skis that it somehow becomes horrible to you. And also working with teams where you kind of share in not only the risks, but you also share in all the rewards, kind of helps. And that's really one of kind of the secrets of these systems, these ecosystems, is that a lot of people have this kind of shared sense of either unintended outcomes. And so if you only look at the metric of whether it was financially successful or some kind of other exit failure, you won't really capture the real secret, because when you look at the trust that's been engendered, so a Jack Dorsey can leave, Twitter and then go and start Square, but you can see all the trusted relationships that follow in behind and then follow them at other places. And that's the real sign of success, not whether a single company or whatever kind of flipped the switch or rang the bell.
Hi, I'm Melvin Leok, professor of mathematics at UCSD. I just wanted to make a comment about the question you had about why it makes sense for a company to invest in sort of out-of-the-box type things, because if nothing else, it's a way to attract the best talent. If you want to attract truly out-of-box thinkers, you want people who are able to sort of, it's like question the assumptions you're making, it's like in all the blind spots, then you need to give them the space. It's like that's, I think, a big part of what attracts people to academia is that freedom. And, it's like industry is able to attract, it's like, the very best talent when it's not always in service of the bottom line. And I think that's a big part of that. With regards to the question of failure, I mean, I think it's like anyone who has gone through grad school understands that if you don't know how to deal with failure and you sort of can't pick yourself up and you can't learn from the experience, then you're never really going to innovate. As a mathematician, it's like, there's this idea that mathematicians do their best work when they're young. And my suspicion is because mathematicians, once they reach a certain age, oftentimes don't want to feel stupid. And the moment you stop wanting to feel stupid is when you don't go outside the box, you do incremental things, and you never take chances. And I think that's
We
really
agree.
important.
There's an expression that foolishness is the cost of genius. And if you aren't, if you're worried about being embarrassed by what you do, you're probably not on the right path for the kind of stuff we do.
Yep.
Any other questions? Let's see. Anyone else? Someone who hasn't asked a question yet. Sure. Let me go around.
Um, so if I wanted to like pitch an investor, how would I at a very early stage, like, and not for a lot of money, but just to like enough to pursue some out of box ideas. How would I do it? Like, I'm working on a project to addict people to real life, and like there's an edge between, I think, like out of box thinking and like feeling a little crazy. So like, how do I like ask for money to like, and where?
That's a good question. And sometimes that line is quite fine. I remember there was, yeah, there was this company. This is years ago. I remember some company came in and pitched Lux, and afterwards, one of the partners said, "He's like, I don't know if that person is like a genius or like a Batman villain." And so, like, you kind of never know. Yeah, I mean, a lot of it is. I mean, sometimes it can be like just cold emails, like a really well crafted cold email. But it's the truth is, I mean, oftentimes it's very relationship oriented, kind of like having connections to people. And so people who are like willing to listen to this kind of thing and know that, yeah, maybe this idea, it might be wild, but it's not like crazy insane. But the truth is also, when you say like in terms of like a little bit of money to kind of experiment on things, I definitely think with certain things around like AI and software at this point, like in terms of building software, the cost has been dropped so low that like it's actually it's very easy to actually experiment and try different things. And so, and at this point, we're in a kind of weird situation where oftentimes when someone has an early idea, they actually have like a working version of that idea very, very early on. But going back to like how to do it, it's often through just like personal connections and kind of like, and some sort of like trusted relationship, so that that person kind of knows that when they're when like the investor is speaking to them, they know that, okay, this is not just some random crazy person.
That's usually the best.
Yeah, I mean, yeah, there are obviously other ways of doing it, but I would say that's by and large like the.
Because when you think about it,
Yeah.
early on, really the only capital you have an ability to bring to the table is a great story traditional attributes of capital. But really, what you want to do is just have this compelling story and a connection to be able to get in the door to tell that story. Which is why you have to be so relentless in doing it, because the vast majority of these things don't pan out. You send out emails, you don't get replies, even if they are through trusted sources. You walk up to people who say they'll follow up with you, and then have trouble connecting. So we also find that the greatest entrepreneurs have this grit behind them, this ability to constantly persevere and just kind of stay with it, send a follow-up email. In fact, from my standpoint, some of the sexiest entrepreneurs to us are the people who I totally forgot they even sent me an email, and they just keep sending me an email, over. But again, there's that, as Sam was saying, there's a super fine line being incredibly annoying, and kind of being a stalker, and being someone who's tenacious.
Yeah, thanks. So our healthcare system's upside down in the sense that we spend all our money dealing with problems that are established, but we can't spend money legally trying to identify problems before they occur. For instance, if everyone in the United States had a PET scan and a genetic analysis at the age of 35 or 40 to do predictive genetics and also to identify cancers before they become symptomatic, we would save untold billions of dollars. So how can venture capitalists and companies like yourself figure out a way to convince insurance companies and governments they could save untold billions of dollars if they turn the system upside down? And the company that does it successfully could reap billions in terms of cost savings, a sharing of the savings, like a qui tam lawsuit, for instance, within the federal government.
Yeah, it's a really interesting question. I haven't thought about it enough, but my sense is that's probably too large for venture in terms of like being able to solve that kind of thing. Like, I feel like there's a lot larger like systemic issues and like incentives. Oh, to like, you mean just to kind of like prove that? I mean, I feel like the argument you basically just made right there, like that should be enough, which shows that the math or computer models is not going to cut it. Like there has to be something else in order for people to actually kind of change their mindset of what these things are. It's not going to, I don't think like a well-crafted argument is going to be the solution for that. Unfortunately, I feel like there's going to be a lot of other factors there, but I'm not, unfortunately, I don't know enough to tell you what those factors are.
It's one of the hardest things to do, because they say the greatest barrier to innovation has never been technological ability. It's always been political will. The ability for people to not only want to change, but then to put that change into practice, which is why. And it's really, really difficult. And there was another quote from the famous writer Upton Sinclair that said, "You will never get a person to see your point of view when their paycheck depends upon them not."
Yeah.
And so if someone has some other alternative incentive to not do something, they will almost do it, because human behavior will always adapt to whatever incentives and rewards. And so if you want to create that upside down model, you first have to deal with the incentives and rewards within the system to drive that human behavior to it, rather than the technology or the process.
Hey,
What?
healthcare system is based on maximizing income, not outcomes. So
That's why during the first Obama administration, he gave all of his cabinet members that paper by Atul Gawande called The Cost Conundrum. Is the reason our healthcare is so expensive is because we have all this wonderful technology. And they said, the conclusion was, no, it's because we're incentivized based on profit motives and hiring that. And there was no correlation between how much we spend and the outcomes we get. And that was a big kind of whoa. But do you think much behavior changed? No, because until you're willing to attack those incentives and reward structures, you won't.
But I think it's also easier to, incentivize people. It's like when you're about to die, right? There's a reason why there's so much investment in sort of healthcare. It's like from rich, really old white people. It's because they're afraid of dying. It's like, they have all these wealth they want to.
But that's an incentive.
Yeah, that's an incentive, exactly, right? But I mean, it's like,
mortality is probably the greatest incentive.
That's right. So, but talking about sort of, it's like you're going to save tons of people who seem healthy.
Right. Like the feedback loop is like distant enough that it doesn't feel compelling. Yeah.
Hey, so I'm an undergrad third year data science major. And my question to you is that let's say if I want to create an app, a software, anything, with little to no innovation, I can create an app, I can get some funding, I can get some customers. But for me to create a startup in biotech, does it have to be innovation based? Like, can I, as a third year undergrad student, create something in biotech without proper research, without creating an innovation? Or do you always have to do some innovation, create a delta, and then sell it to companies or the government or something?
I, I, so when you say like creating like an innovation, you mean like some sort of like technological or some sort of like conceptual advance? I mean, for me, like the kinds of tech that Lux looks at always has that sort of conceptual advance, even in kind of the complete, like the entirely software domain. So, I mean, yeah, there's lots of different kinds of companies that can be made. And in the biospace, certainly you can do things even just in software. I mean, there's a lot of like informatics and things like so people talk about like there's biotech that often requires a huge amount of capital, but then people are increasingly talking about kind of the opposite, where it's like more software based, called tech bio, which is probably not the best term, but like that's kind of the term that people are using instead of biotech. That being said, so I think there are ways of building maybe a company that's related to biology for a lower amount of money. But ultimately, I still think it requires some sort of conceptual advance, because you have to create something that is novel and of value for people. And it's going to be probably many orders of magnitude more complex than, I don't know, like Candy Crush or something like that. That being said, I mean, I feel like even in just the like pure software realm too, there's a lot of really interesting work happening there that is also requiring conceptual advances, like in terms of like finding new mechanisms for like democratizing software creation or new ways of coding or whatever it is, or managing large data sets. And that often requires conceptual advances too, but it doesn't have to. So yeah, that's a long way of saying I'm not sure if like the amount of like financial resources isn't necessarily the right indication of whether or not there's like some sort of like conceptual advance. It's there can be like technical risk and lots of things like that in every domain. So
No, in the biopharma, it's easy. People repurposing drugs,
Oh, that's
finding
true.
exactly use cases for it is another way. You just have to have, for an investor to be able to invest in you, you just have to have a value proposition that is differentiated enough, and that we feel you can sustain that differentiation at least until we get our money back of some sort. You can call it a competitive advantage. You can use all this other language, but we'd have to see that there's something around that. But sometimes it doesn't have to be even huge. A lot of what people are doing, the AI in drug discovery for biopharma, we've seen companies that are saying, look, we're not trying to develop, the next major cancer drug, but we can look at some kind of therapeutic that's already gone through all the heavy lifting of the regulatory process and find something right behind it that's just different enough, if the market's big enough, that where we can just like ride on right behind their coattails and get a piece of that market, which is good enough, and still build a very sexy business from it, and that's good enough. So sometimes it's a matter of subtlety and nuance to it. And by the way, a lot of successful companies have done that. Back there, and then I'll bring it.
Yeah. As a science officer in your company, Sam, you probably deal a lot with uncertainties, like you said, right? And investment store is finances, right? They want certainty. How do you deal with this, with them looking at you to give them something certain while you actually can change your mind tomorrow?
So I mean, the truth is,
Examples,
even on the investment side, there's a lot of uncertainty, and so you're always making decisions under uncertainty, and you often have the opportunity though to actually revisit those things. And so if you invest at a very early stage within a company, then you can decide, okay, like 18 months later when they're raising another round, like have they actually eliminated some of the risks and the uncertainty that you saw earlier on, and then you invest again, and then you can you can see these kinds of things, or if you're on the board, helping them actually actively eliminating the uncertainty. So I don't necessarily think it's a matter of like I mean, yes, you might have to make a decision, but decisions are always made under a certain amount of uncertainty. So I'm not really sure I would view them as different kinds of things. Right. Yeah, like the risk reward kind of relationship.
And that's why we love. So we say the right balance when we look at entrepreneurs. There's this balance between optimism and skepticism, and the perfect balance for us is what we call productive paranoia. Where we want people to understand that there definitely is uncertainty, but that they think they have strategies for dealing with that uncertainty, as opposed to the blind optimism where this can't fail, we see the future perfectly, and nothing's going to hit us, or the people who are constantly so obsessed with finding more and more data that they can never move forward with the idea. And so in between, there's a happy medium.
Right, and some of the most like successful entrepreneurs are the ones where on the surface you would say, okay, they should be like not quite resting on their laurels, but not necessarily feeling as competitive because they've already done so much. And of course, they are often the most like monomaniacally competitive and paranoid, and like even, and they're like focusing on all these like things that you would think are almost trivial, and so they're sometimes like, oh, like you would never want to spend a lot of time with them, but as a founder and a CEO, like they're doing the exact right thing, which is like focusing on all these things and trying to reduce as many risks as possible. And so yeah, but also right, there's the productive component of like not being paralyzed by that indecision and the uncertainty.
And there's a great investor in the Valley who I respect a lot, and he says, I love it when entrepreneurs spend more time trying to understand what they don't know than kind of building upon what they do know. It's just this kind of fitness to them.
Yeah, so coming back to the tech bio space, I've worked in that for some time, and one problem that I've frequently heard about is that you can sort of develop like the best platform in the world for drug discovery, but at the end of the day, it needs to be validated on an actual clinical drug. And oftentimes, like companies will only have the capital to do that for one drug. So if they fail, their entire stack just sort of becomes like disregarded. Do you see any sort of approaches to maybe get around that? And if someone has a very valuable platform, but maybe their first validation for that like goes wrong, do you see like how they could possibly pick up from that and go on?
Yeah, I don't know if you want to take this one. This is an area that I don't actually know enough of the details, so I don't want to speak out of turn. I don't know if you want to if you want to take that.
That happens more than you realize. These people who have these serious, because especially in the biopharma space, a lot of things just don't work out for various reasons. Whether it's in kind of the early work or whether it's in phase 1 or even phase 2. So you can't possibly know that. One of the ways you can de-risk is through partnering, finding people to partner who will kind of absorb some of that risk. We call it risk allocation, kind of finding that. Another way is, if you personally have credibility in terms of the science and you prove the science, then particularly in this day and age where people are using a lot of AI and other tools to kind of validate the clinical work before they kind of put the compounds in front of the investors, they're making the decision based on the same data you're seeing. So if they make a decision to invest, they share every bit as much as that risk as well, because all you did is kind of help them see that. We haven't seen that it's been too stigmatizing. We've seen people who don't do it. And even on the tech side, even outside of biopharma, Ron Conway, when he took a meeting with Sean Parker about Facebook, made a lot of money off that. But Ron said almost every other deal that Sean brought us before that was I lost money on. But someone earlier was saying that, I think it was you, who was saying, part of the reason that venture even works is, and you were saying it too, Sam, is that worst case scenario is you lose one extra capital on most of these things. Best case scenario is you get these huge wins. And so it's almost not what do you gain, by investing, is what do you lose by not doing it. And that's why the reason that alternative assets in general, particularly venture capital, even work at all. It's probably shouldn't say, in a record set, but it's a form of legalized gambling, that you do. and you just think that you're smarter or better, because even the very, very, very best funds, still have a batting average that doesn't get them into the majors on this stuff. But when they kind of do it on this side, in a portfolio of 10 to 15 companies, if you have one of these winners, no one even remembers the names of all those other ones that didn't work out. Right?
Yeah, that's completely true, right? It's right. It's very much like, yeah, that like heavy tail distribution of like 1 out of 100 is this huge winner, and then like, yeah, 10 out of them.
It's called the power law.
Yeah, exactly.
So it's called the power law. In fact, 4% of all investable deals that get invested every year are responsible for 80% or more of all the returns in the market.
Yeah.
So you just have to embrace the power law.
Yeah, which I mean, and yeah, the problem with that is, as humans, we are not we don't think intuitively about power laws. We're very comfortable with like normal distributions and things like that. And if like height, for example, were not normally distributed, it would be like you would walk down the street and occasionally someone would be like 100 or 1,000 feet tall, and that's very hard. We can't imagine that because that's not how it works. But that's the kind of thing that happens with these kinds of outsized returns, and so it requires a very different sort of mentality in order to kind of think about these kinds of things.
Hollywood works on exactly the same model.
Yeah. Right. Yeah. Any sort of hit-based industry. That's exactly how it works.
It does, actually. You're exactly right.
Hi, my name's Aryan, and I'm a third year bioinformatics student. And my question was kind of also building on the previous questions that at this stage in my what I view my career path ahead, I know for sure that like bioinformatics as a data analysis, like the data analysis part of that, is now a lot relegated to just prompting ChatGPT. I personally work in a lab as well, and it's literally that's what it's been reduced to. So I don't particularly see much future there, especially in down the line. It's doesn't look very promising, and uh, I do know that I personally really love biology and thinking about it, and um, a big hurdle in the bio entrepreneurship space. Like today, if anyone wants to build a customer product, D2C product, there are very less bottlenecks for even a college student, a third year undergrad. Even a high school student can just build an app, go out there, get capital from people, and go out into the market, and you'll get your revenue in your first year if you build something good. But in the bio space, if you don't have access to a lab where you can validate your idea in in vivo, and um, so what kind of validation do investors look for in an idea? Like at what stage of the validation is there like a particular stage of validation where which investors look before they want to even consider that? And how does anyone without capital or accessibility who might have an idea in the space, how can they go about that? And kind of second question for you, I'm more interested in also interested in knowing how you kind of thought of your career at the time you were a student, and what did you see yourself going into? Because I I, uh, I think you have a PhD in computational biology. If I
Yeah. So I'll answer like the first part at least kind of briefly, and then I can tell you a little bit more about the career. Yeah, I think the truth is it kind of depends on the biological idea. So like for example, if you are a well-regarded professor at a university and you've already spun out companies on the strength of like 1 or 2 good papers, like you can incubate a company from the ground up around that, and then kind of do some of the more of the validation within the company. Other like if you do not have that kind of track record, it might require a little bit more. And then yeah, to kind of do things, especially sort of outside of the traditional modes. yeah, it would definitely be harder to kind of, I guess, build a lab kind of on your own. That being said, I mean, I've seen people who just like buy bio lab equipment on eBay, and like you can actually do a lot with those kinds of things. I'm not necessarily sure that's like the best way to validate some of these kinds of things, and certainly for like clinical trials, you can't do that. But there are people who have actually even done just like independent research in biology around some of these kinds of things, and so I wouldn't necessarily view certain kinds of things as like blockers entirely. Going to the second question about like my own career, yeah. So when I finished my PhD, I initially thought, yeah, I wanted to continue on in academia. I wanted to be a professor, and then so I did a postdoc, thinking that I wanted to continue this kind of thing. And so during my postdoc, I was doing research in a number of different areas, but then alongside this, so I was doing research in like many different fields, kind of applying these like mathematical approaches to lots of different things. And then alongside this, I had started writing for general audiences. So I had started writing for like newspapers and magazines about science and technology and mathematics, as well as begun writing my first book. Despite all that weird stuff, I still thought, yeah, I want to go into academia. And actually, I went on the job market my final year of my postdoc and was getting interviews. And I remember it was during one interview where I think I was meeting with the dean of the school where I was interviewing, and he said, "We like you a lot, Sam, but how would you fit into our department?" And I remember thinking in the back of my mind, like, maybe academia is not going to be a fit for me, because I was like doing all this weird, like, you don't write like books for general audiences. Like, and actually, even one of my postdoc advisor, he even said at one point, like, you should wait until you have tenure for doing these kinds of things. And at a certain point, I told him, I'm like, this is what I want to do. And then he was actually incredibly supportive, which was wonderful. But I knew that the kind of stuff I was doing was not the traditional role. And so after, like, so in the final year of my postdoc, when I kind of realized that this was not going to be a fit, I began kind of exploring lots of different things. And yeah, my first step outside of academia, we were talking about this earlier, was the Kauffman Foundation. It's a large philanthropic foundation devoted to kind of understanding entrepreneurship and innovation, education. And at the time, they were building this research and policy team, sort of like an in-house think tank. And I had been brought there to like for some little conference. And so after I was realizing I didn't want to continue on in academia, I was talking to one of the people who I had met there, and he said, "Oh, we're building this research and policy team." And so I ended up joining them. And it was one of those things where the moment I took like one step outside of academia, I realized that some of the things I had been thinking about and like been concerned with did not actually matter, at least, or there was like a lot of games that had been played that I didn't need to be part of, and it was very liberating in some ways. And then from there, and then after that, I ended up at Lux, and I've been with Lux now for over a decade at this point. But yeah, I'd never had a very clear path. It's been kind of very circuitous and very happenstance, and like I can tell a nice story after the fact and say like, oh, like all my exploration in lots of different domains and engaging with the public and engaging with foundations in the startup world has led me to being able to do this kind of thing in the venture world. And that's a very nice story after the fact, because during the time I was making it all up and I had no idea. So that is the real way it worked out.
What research are you personally the most passionate about right now?
You mean research I'm doing or research that I'm seeing? And to be clear, like, I'm not actually actively doing like scientific research myself. In terms of, do you mean like research that I'm just like seeing and like following?
Research you're seeing and research you would love to do.
Oh, okay. Ooh, let's see. I'm trying to, so one of the, so given my role of like exploring lots of different topics, I actually have this like, this file on my computer, like all the, it's actually like a Trello board of like all the weird ideas that I'm thinking about at any one point. And so now I'm going to kind of like mentally go through the different areas in research. I would say, so one area that I'm very interested in, and it is actually happening, is just the sort of like non-model organisms and sort of comparative biology space. And so the way I kind of think about it is, so I'll give an example. So Lux is invested in this company called Variant Bio. And so the way what Variant Bio does is says, like, obviously there's variation among humans. So like some people are taller than average, shorter than average. Some people need to sleep a little bit less or a little bit more, but they're also extreme outliers. Like some people who need to sleep very little, or certain populations that maybe metabolize fat completely differently. And Variant is trying to actually find these genetic outliers and use them as kind of the basis for developing pharmaceutical assets. And that's all within humans though. But imagine you can do the same kind of thing across the entire tree of life. Most biology is done studying model organisms. And so like we spend a lot of our time studying mice or studying zebrafish or fruit flies. And we've learned a lot by using them, by studying them. But if there's certain things you want to study, so like, I don't know, hibernation, you can't study like a zebrafish because as far as I'm aware, it does not hibernate. And so you actually need to study other organisms. And so you actually need to sample the entirety of like all the different branches of the tree of life. And people are beginning to study kind of and so there's like the whole field of comparative biology, people who just study weird organisms. And like they find like, I don't know, some fish that has like, it actually generates its own like antifreeze and it's equivalent of blood or whatever it is, which is kind of wild to see. And there are a number of companies and things kind of trying to do this. I just want to see that like more and more of like really trying to understand the entirety of the tree of life. Because like at this point, I don't even know what fraction of all of life we've like even identified. Like the number of like we know that there's a huge number of species like on the planet that we have just never even seen or identified. And so there's just so much unknown, and it will actually teach us a lot more about the true like variety of biology and the true strangeness of biology. So that's certainly one area that I think a lot about. Another one is just related to thinking about like large-scale simulations. I feel like we're kind of in this really interesting place where up until recently, simulations like to simulate some like very complex model like the weather required a huge amount of computational resources, and it's still really, really hard. We have a pretty good handle on it, at least out to like, I don't know, 10, 12 days or whatever to predict the weather. But now actually through certain AI models, we're able to kind of use the advances of these more kind of like more like traditional computational models, but to actually do really interesting simulations in a way that we might never have been otherwise able to do. And my dream is almost like, and I mentioned before that I was like inspired, like I played SimCity when I was little. Like I think, and if we can actually like democratize simulation, like people should be able to like spin up their own model of like SimCity. Like I don't have to, so like Will Wright, the creator of SimCity, he had a whole bunch of assumptions in SimCity. I don't have to take those as given. I should be able to build whatever weird one I want, and make it as realistic or unrealistic as possible and really try to understand those kinds of things. And I think we are entering maybe a new golden age of simulation, but I want to see more of those kinds of like really large scale things. I'm also very interested in like artificial life, which is the ability to actually encapsulate certain ideas around biology and evolution in silico, actually like evolve like digital organisms as well. So those are just a few weird ideas that I spent a lot of my time thinking about.
Hi, my name is Rushi, and I'm an undergraduate student. I just had a question about mentorship. Earlier, you talked about how important your postdoc was. He was incredibly supportive of what you wanted to do. And I had a question regarding how important is mentorship, and how do you find mentorship in a field that can be something like very niche, like venture capital and biotech, for example?
Yeah, I mean, so yeah, I mentioned my postdoc advisor. My grad school advisor was also incredibly supportive. Both of them actually, they in addition to doing all of their research, they also actually happened to write for general audiences, and so that was one of the things that so they were very supportive of when I was thinking about those kinds of things and very interested in that. And so yeah, that kind of mentorship was invaluable. In terms of venture, I guess I didn't really have like a traditional kind of like mentor. I ended up at Lux, and then I guess I learned a lot from the Lux team, which was enormously valuable. But in terms of finding the right mentors, I'm trying to think of how to. I mean, it's not an. I don't think there's an easy path. Like going back to the experimentation part, I mean, a lot of it is like spending a little bit of time with people and seeing if you resonate with them, and then kind of doubling down. And so, in the world of grad school, like you might decide if you might want to work with someone and then realize, oh, that's not actually the lab I want to be in, and maybe you have to switch. And so I don't necessarily think there's any sort of magic sauce. I think it just kind of takes time and effort and like finding someone that you resonate with.
So essentially, you just want to go around and explore your options and see what really resonates with you the best, and then
yeah, I mean,
based on that,
and the other thing is also, I mean, to a certain degree, especially if you're trying to kind of carve some kind of weird path for yourself, try to find people who already are doing maybe some subset of the things you're doing and reach out to them, but also just try to see how they ended up where they did. And that can kind of give you insight of like the kinds of paths that might make sense for what you need to do. Especially like the weirder the thing you want to do, you'll probably need to have some sort of like overlapping set of mentors as opposed to a single one, especially if it's going to be kind of a weird or kind of like N of one kind of thing.
Thank you.
Reach out to a lot of different people, because some people will be life mentors, some people will be career find someone that you want to emulate, not replicate. It's not don't want to be them, but someone that has values or ideas that you find interesting and you just want to learn more about them, or people you believe have this inherent wisdom that you would like to kind of learn from.
I kind of have one more question about academia and research. Like, personally, when I work in my lab, like I kind of feel that a lot of one reason that I feel that research might not be for me is that you can even though you're not working on the wet lab side of things, you can still feel that you're working on a single thing for like months on end, and you don't see where it's going. Like you're waiting on the staining, you're doing the data analysis, and it can take forever, and it can also turn out to be nothing, and it can also turn out to be something. The uncertainty is not what bothers me, but it's more um, not seeing the macro goal. And there's also kind of a voice in my head which says that, oh, no pain no gain, and you have to work through it. And um, and then that's one of the other reasons why I consider, like, I personally always had an interest in finance, and that's why I also considered bio VCs or something like that as a career path. So is that aspect of not seeing where you're getting to in a bio VC still the same as academia? Because it's kind of that you're getting to see new companies or new people who are doing new stuff, maybe not every day, but every other week or so. And you're getting to kind of think about if they're worth investing, or if there's value in that. Um, and I know that I certainly like to do that. So, like, do you think that that aspect of academia is necessary in every field in life, or do you think it's more of a personality fit that some people are just okay and some people are not?
And so, in one aspect of venture, like there is a long feedback loop as well. There, I mean, like, it's a different kind of it's different than doing research. But I mean, when you make these bets, you will not know if those bets are correct for a long period of time. So I think in that sense there is some similarity in terms of like focusing on a very long project. Yeah, you're right. It's not a bad or good thing. It's just kind of right whether or not it resonates with your personality. There's ways of doing research, I think, that has a kind of shorter time loop. I also just know personally that I have I would say that the positive ways I'm interested in many things. The more realistic way is I have a very short attention span, and so I have to kind of lean into that. But and that being said, most VCs have very short attention spans. But when it comes to like the feedback, it is going to be very long, and there is going to be that kind of that delayed verification of like whether or not those things have actually been successful or not. Right. Yeah. You definitely have to be right. And I think, and that's often, and going back to like one of the reasons I enjoyed kind of like speaking to general audiences and kind of writing is because I really enjoyed that kind of thing. And right. And there are some scientists who are really, really good at that, and they are the ones who are very comfortable working on the thing that might not have like it might not have a payoff for years because they know like what the larger picture is. And right. And so I agree, like that kind of ability to not only articulate it, but also to internalize it, I think is really, really important.
I wanted to ask, thank you for coming, and nice talk. I wanted to ask how you guys underwrite the risk of going to market on the Valthos deal, and understanding that taking the head of Palantir's life science division, knowing Palantir's revenue is mostly derived outside of the life sciences, and basically building software for countermeasures. How do you guys think through the sales cycle into the DoD, and a pretty small team at Palantir, or even smaller team at Valthos? How are they going to tackle that?
I mean, I have to be honest. I was not very involved in that, so I don't have a good set of insight. And so also, in case it wasn't clear, so even though I am like I'm part of Lux, and like Lux is a small team. I'm not on the investment team myself, and so I'm not making investment decisions. So yes, I'm not gonna I'm not gonna have anything insightful on that one. But yeah, sorry.
Well, if we don't have any more questions, what we can do is invite you to, we can end the program, invite you to come up, have a conversation with Sam. Join me in thanking Sam for joining us today. And as we said at the beginning, if you go to innovation.ucsd.edu, you'll see all the programs we're doing. This one, Innovation at the Edge. We also do a program called Meet the VC. We have the Basement Incubator. We've got the Essentials of Entrepreneurship class, and we've also got a Capital Fitness class as well. But we've got a number of kind of programs, including the Innovation for National Security and the I4X Incubator program. But we have so much going on. If you want to kind of explore things, or if you just need access to certain resources, please just let us know. We will act as a concierge to make sure you get where you're going on this journey. So, Liesl here. And thank you. And for many of you who this first time, we hope it won't be your last time here. And we thank you, and we'll let you kind of go on with the rest of your evening. Thank you.